This is our experimental set for determining the characteristics of a PN junction diode. Both the forward and the reverse characteristics can be determined using this set. It consists of a dual power supply, a 3 volt and a 30 volt power supply, which can be switched using this switch. We have a voltmeter over here having dual range, 3 volt and 50 volt. And we have a ammeter over here having dual range, microampere range and a milliampere range, which can be switched using the switch. We have a manual over here which has all the details. For example, the aim, the apparatus required, the theory for the experiment, the diagrams, and also the procedure for the forward characteristics as well as the reverse characteristics. We have also provided with experimental data and the graph. These are only sample data. This will vary with every kit. This is the data for the reverse characteristics, and we have the precaution discussion. Also, we have the circuit connection given for both the forward and the reverse characteristics. So for the first part of the experiment, we will be connecting for measuring the forward bias. So the positive of the power supply is connected to the positive of the circuit. The negative of the power supply is connected to the negative of the circuit. The positive of the voltmeter is connected here. The negative of the voltmeter is connected here. The positive of the milliammeter is connected. And the negative of the milliammeter is connected to the circuit. Now, for the forward bias, the switch position should be at the 3 volt range, and this will also be at the 3 volt, the voltmeter range. And the milliammeter will be towards the milliammeter position and not the microammeter position. I'm just zooming in so that it is easier to see. This is the diode. It will be connected like this. As you can see, there's a gray band over here, and it will be connected towards the negative side. Now make sure the knob is in the minimum position before we switch on the kit. We will start increasing the voltage, and until it reaches the forward voltage, there will not be any appreciable amount of current in the current meter. So it's around 0.4 volt. The current has started to increase, 0.5. So we will note the voltage readings along with the current readings, and we will plot a graph between the voltage and the current in order to obtain the forward bias characteristic curve. After we are done with the readings, turn this knob to the minimum position before we switch off the circuit. Now for the second part of the experiment, which is to find the reverse characteristics, we will simply change the polarity on the circuit over here. We will not touch the diode, we will not touch the connections on the voltmeter, ammeter and the power supply, but we'll simply change the polarity on the circuit. So the positive terminals are connected at the negative positions, the negative at the positive positions, and also for the milliammeter it will be reversed. And now for the reverse characteristics, this will be at the 30 volt range. This will be also at the 50 volt range, and this will be at the microammeter range. Let's switch on the circuit. All right. So now we'll start increasing the voltage, and we'll note the current in the microammeter. Since it's the reverse current, it is very less in amount, like it's 0.008 microampere, which is 8 nanoampere. So we'll slowly increase the voltage and we'll note the reverse current in the current meter. We will note down the readings for the from the voltmeter and the microammeter. Make sure it's at the minimum position before switching off the circuit. So as you can see, if we are noting down the voltage and the current readings, we will be obtaining a graph for the reverse characteristics, as well as from the previous reading we will obtain a graph for the forward characteristics. So this concludes our experiment for determining the forward and the reverse characteristics of a PN junction diode. Thank you.
Please subscribe to our channel for more such videos. Thank you for watching.